today we are going to discuss about functions, right? We have already done with the relations. We are going to discuss what function is basically. So you know that what is function? From a set to Cartesian product. Cartesian product represents all the possible relation, and in that particular relation, if you pick something, like some elements from that particular Cartesian product, then they can give you a relation, or you can say that functions, okay, that have some functionality, right? So for example, let's say I have a relation R on n cross n, right? And n cross n, you know that, right? Or set of all natural number and set of all natural number, and I'm gonna make a function. Now a relation R is x comma y such that y is equals to x plus 2, right? And of course x and y both belongs to natural number. X and y both belongs to natural number because of this, right? So, and now this is a function, right? The y equals to x plus 2, or I can write it like this: fx x plus 2. Okay, function of x means, what do you mean by function of x? Functionality of this particular part is dependent upon x. That is why it is known as function of x. Okay. Now, for better understanding, let me introduce it like this way. Okay. So this is one set and this is one set. So this is n, this is n. Now each value of this is related with everything, each and everything, and for the same thing, each individual is attached with all possible values in this end, and all possible values of the here is related with this. So this is the result of Cartesian product. We just grab some of them because, depending upon functionality. For example, if I put x equals to 1, then y is equals to 3. If I put x equals to 1 here, this is x and this is y. For x equals to 1, I can only get 3. Okay. Now 1 is not related with any other thing. Okay. So 1, let's say 1 is 1. It is not related. So in functionality, you are not going to consider this part. So this is what function is. Function is basically a subset of a relation. You can say that. It is a subset of a Cartesian product. Okay. So this is what function is. So you know that you might have read it in your 11th class. Now here we are interested to find the inverse of a particular function. Okay. So what is the inverse? So you will know about it later on. But in order to find out the inverse of function, there is two things that we have to keep in mind. First one is one function. Okay, one function and onto function. So you don't know about what one or what onto is, but you are by this lecture it is going to be very clear. One means basically what happens is, one relation means one entity from this relation is related with exactly 1. Okay, if for one value of x there is only one value of y, then that type of relation is known as 1. Okay, and I'm just briefly explaining you what we are mean by inverse. Okay, so means, let's say this is set A, this is set B. Okay, and functionality is something like this: A to B means if you put A, you are going to get B. Okay, so for each value of A there exists some value of B, means for A there exists some B. Now the question is like this: if I make some new function such that if I put each and every value of B, okay, so means it is basically a domain, right? And it is a range. If you put in function, for all the domain there is a valid range, right? And if we change them, right, if there is some new function such that if the range of here act as a domain over here, and domain of this act as ranges here, okay, then such a function is known as inverse. And this criteria can be obtained, means I can get that function gx only if they follow some rules. The first one is known as 1, that is injective, and the other one is known as surjective, right, onto. So if a function follow these two methods, then we say that their inverse exists. And okay, so that is why we are interested to check whether a function is injective or bijective, injective or surjective. If the function follows those both of this, means a function is injective as well as surjective, then the function becomes bijective, and only bijective functions have inverse. Okay, so okay, all right. So according to, so you know that why we require one function. Okay, so for a function, if inverse exists of that particular function, then it should be one. So one function. I think you must know about it. Okay, in 11th class you might have learned about this. So one function, or it is also known as injective function. Okay, injective function. So what one function is? So if each, so let's say this is set A, this is, let's say this is set B. Okay, if each entry of this, each element of A is related with exactly one element, then that type of function is known as one function. Okay, so there is one function, and there is many one function also. Okay, so you should know about this. What is many one function? Many one means there is two or more values for which the function has same value. So such function is known as many one function. Many one. Okay, and one means exactly one-to-one mapping. Okay, so this is one function. So it is very important to understand why we how to calculate whether a function is one or not. So in graphical method, it is very hard to identify. So let's say the domain is all real number. Okay, so you are going to it is impossible to write all real numbers and then check for them that they have exactly one relation with B or not. Okay, so that is why we are come with some algebraic formulas. So if I have a function fx, okay, now if fx1 equals to fx2, right? So fx1 means the value of fx1 at x1, right? Value of fx1 at x1 and value of fx2 and x2. If both values are equal, then this should imply, means if you put these two equal, after simplification they should imply that x1 is equals to x2. If it is happen so, then we say that the function fx is injective, right? Okay, so once more, so it is something like this. Let's say this is this is x and this is fx, right? Now it says that at x1, let's say this is x1, so this value will become fx1. This is what we mean, right? And now if it is x2, this is x2, then the corresponding value here will become fx2. Now if these two are equal, okay, so these two are equal. If these two are equal, means they are not different, they are same thing. So what it means, this point is fx1 and fx2. This is what we mean, right? Both values are same. So what this implies? This implies that it means these two should be same. If this happens, right? If these two are same, then they are not two different entities, they are same. So this should happen here also, right? Otherwise it will become many one, right? Many one means two values will have same thing. So that are not one. So we are interested in one, right? So this is what we mean. So x1 and x2 should be equal. So if you are solving this fx1 equals to fx2, then this should imply x1 is equals to x2, right? So please keep this in mind. Now we will solve some question, and after that it will be very clear. For example, let's say this a function fx is 2x plus 3, and now we want to check whether it is 1 or not. So fx1, put fx1 equals to fx2 and solve it. 2x1 plus 3 is equals to 2x2 plus 3, right? 3 will cancel out with 3, so 2x1 is equals to 2x2. So 2 will cancel out with this, x1 is equals to x2, right? So this implies this, so that is why it is 1 1. And if you draw it like this, their mapping, if you draw this, so 1 2 3, so for each value, for if you put x equals to 1, you are going to get 5. If you put x equals to 2, you are going to get 7. If you put x equals to 3, this is going to be 3 2 6 3 9. Okay, 2 2 4 3 7. Yes. So for each value of x, there is unique value of fx. So that is why it is 1 1. So if this implies this, then you can say that the function is 1 1. I will tell you what is the importance of 1 1 function in order to calculate the inverse, right? But for now, just understood this. Okay. So this is how you have to calculate 1 1 function, to check whether a function is 1 1 or not, right? Yeah. Now let's have some examples. So for example, the most famous example is this: fx is equals to x square plus 2, and you have to check whether it is 1 1 or not, right? So what you have to do, you just put fx1 equals to fx2, right? Now x1 square plus 2 is equals to x2 square plus 2. Now 2 will cancel out with this, and one more thing, they sometimes write like this, r to r, right? What does it mean? It means first r is belongs to x, means all x in this expression belongs to r, and here r means all value of fx belongs to r. So this is what it means. So remember this. So this will cancel out, and x1 square minus x2 square equals to 0. x1 minus x2 and x1 plus x2 is equals to 0. So x1 minus x2 is 0, and x1 plus x2 is equals to 0. So x1 is equals to minus x2 here, and here it is equals to x2. So now what you can see, here are two values, right? x1 can have two values for which the fx is means for which fx1 is equals to fx2. So this is exactly not one function. For example, let's say x2 is 2. If x2 is 2, then x1 can have value of 2 and x1 can have value of minus 2. This implies this implies this, and both belongs to all real number, means both can be considered because both are real, right? 2 and minus 2 both are real. So that is why this function becomes this function is not 1 1, right? Because there are two value of x1 for which this thing holds. So that is why it is not function. So you can think of it like this: at minus 2, at plus 2, right? So real means all real number, na? Anything can be considered. So minus 2 to 2. So minus 2, the value is going to be 4, and for 2 also the value is going to be 4. So that is why it is a minimum, not 1 1. Okay. So I will show you how the things changes. So if the same question, the exactly same question is written like this, n to n, right? And fx is defined as x square plus 2. Now the question has been changed. Okay, so this thing is very important, right? So please remember this. Now same thing, you have to do same thing, right? You for this also, from here also you have to do the same thing. Now, but here it is saying that x1 is equals to x2 and x2 is also equals to minus x2, but this thing will not consider. Why? Because x1 cannot have a negative value, right? So the value of, so for here the values can be 1 2 3 4 5. If you put any value of this in x2, you are never going to get negative value, because x1 if x1 is negative, then it is not allowed to be put here, right? Because natural number is not negative, right? So please pay attention over here. If the question is this in place of this, right? Now it is saying that x could be natural only, right? So if you put x2 as a natural, then here it is saying that x1 will become negative, but it is not possible. So this will be discarded for this particular problem, and only this one will be considered. Okay, for this particular this specific question, if their domain and range changes, then whether the function is 1 1 or on 2 is also changes. So this function is 1 1. If you're not getting this, please do comment. I will try to elaborate once more, but I think it is very clear. Okay, so x1 is equals to x2 and x1 is equals to not x2. So for this particular domain, both are allowed. If x2 is 2, then you can take x1 equals to 2 and x1 equals to minus 2, because the domain belongs to real number. Real number allowed both positive and negative numbers, but here it is a natural, so you can only take positive values. Okay, so that is why it is 1 and it is not 1 function. Okay, so this is how you have to do. So I'm just showing you one more example, that way it is clear. But this is the best way that by which you can understand it. Now next question is x cube minus 1 equals to 0. Okay, sorry, x cube minus 1 is equals to fx, and the question is like this: function is real to real. Function is real to real. Okay, so what you have to do, you have to check whether it is 1 1 or not, right? So what you can do is fx is equals to x cube minus 1, and this can be x minus 1 bracket में x square plus x plus 1. Okay, so x minus 1 equals to this, so fx is this, right? So what I have to do, okay, I have to check fx1 is equals to fx2. So for this particular thing, it is going to be x1, 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 or I should write it like this: fx1 equals to this. This implies that x1 cube minus 1 is equals to x2 cube minus 1. So 1 will cancel out with this. This will come here, x1 minus q, and x2 minus q is equals to 0. So x1 minus x2, and here it is x1 squared plus x2 squared plus x1 x2. This equals to 0. Okay, so this gives x1 equals to x2, and if you solve this, so what is x1 is? Okay, if you solve this, so x1 is equals to, it is a quadratic, right? So you can solve it like this way. So x1 is this, and minus b, you can say that, so minus x2 plus minus under root b square, which is x2 square minus 4 ac. So what is a? A is going to be, if I am taking x1, 1, and what is c? C is going to be x2 square divided by minus 2a, so minus 2, right? Now if you substitute any value of x2, right, anything, right, x2 from r to r, you are going to get a non-real value of this. So let's see. So if you put 0, so it is going to be 0 minus 0. This is going to be 0. I guess x2 is real to real. So if you put x2 equals to 0, what will happen is 0 minus 0. So under root 0, right? Under root 0. Under root 0 is basically not defined, huh? Or you can say that it is 0, but x1 equals to okay, for 1 point it is happening, so x1 at x2 is 0, it is 0, but for other values, for example, if you take x2 as 1, right, so for x2 is 0, x1 is also 0, so there is no difference actually, right? So if you put x2 equals to 0, both are going to give you the same values, right? If you put x2 equals to 1, so here x1 is going to be 1, and x1 is going to be something else which is not real, right? It is saying that real to real. Or if you put a 1, so it is going to be 1 minus 4 under root minus 3, which is a non-defined term, which is a non-real term. Okay, so x1 is not real for this particular, for any value of x2. At 0 it is happening, so both values are equal, so no worries about that. If it happens that x1 is something real, right, x1 is something real from here, and here it is also real, but both are different. In that case, you can say that this function is not 1 1, but here it is 1 1. Why? Because for any value of x2, this is going to non-real values. Okay, so if it is a non-real value, so that part will be discarded, because x is allowed to have only real values, right? For here only one case is considered, so this case is considered and this will be not considered. Okay, and you have to write a reason for this. For all x2 belongs to R, x1 doesn't belongs to R1. So that is why it will be discarded. You have to write it in word. So there is only one possibility, that x1 is equals to x2. Okay, so by solving these, I'm able to get only one value, means x1 is equals to x2. So that is why this function is 1 1. So this is how you have to check 1 1. Try to solve more questions on this basically. So that is why you will know about it. Okay, I'm going to give you some questions about this. Try to solve it by yourself. So the function is R to R. So one problem is this, and second problem for the same is natural to real. Okay, for the same problem it is going to be real to natural. Okay, try to solve this for all the three cases. Okay, whether it is natural or not, means whether it is 1 1 or not. And the second question is like this: fx is equals to x square minus 2x plus 3. And the third one. And for this it is real to real, one case, and for the other it is natural to real, okay, or natural to natural. And the other one is fx equals to x cube plus 1, right? And the relation is like real to real, or something like this. Okay, so these questions you have to try